In this video, we'll be learning how to add numbers that are written in scientific notation. Looking at this very first problem here, we have 6.5 times 10 to the first plus 3.5 times 10 to the first. Now remember, we want to line up decimal points, and so it's really important that we remember and we understand that the times 10 to the nth power, whatever this is what sets the decimal point. So when we add and subtract any decimal values, we need to make sure that the decimal points are lined up. So as we move forward on each of these examples, we want our two values, okay, whatever this is, y times 10 to the nth, this could also be minus, we want these two powers to be the same. Going back to this example, 10 to the first, 10 to the first, they're the same. That means the decimal point is going to be in the exact same spot. That makes this problem a whole lot easier. But I'm going to show this two different ways. First, I'm going to prove that the decimal points are in the exact same spot by writing these into standard notation. To do that, we have to move the decimal point one place to the right. So this is 65 plus 35. 5 plus 5 is 10. We got to carry the 1. 6 plus 3 is 9. Plus 1 is 10. So we have 100. Now we want to write this back into, so we added our numbers. Finally, what we're going to do is write in scientific notation. To do that, we take our decimal point that's at the back of the number and we move it until there's only one value in front of the decimal point. This is 1 times 10. We moved it 2 places to the second power. But how would we do this if we wrote it like this? Well, since they're the same, I'm just going to bring down this times 10 to the first. 5 plus 5 is 10. There's my decimal point. 7 and 3 is 10. So I have 10.0 times 10 to the first. I move my decimal point one place to the left. So I have to add another power. And that gets us 1.0 times 10 to the second power. Both methods work, and both methods will continue to work moving forward. But for the next example, I'm going to primarily use this method here. This time, we have two values that do not have identical decimal place values. So in this situation, we have 7 times 10 to the first, and we are adding 4 times 10 to the negative 2. I want to rewrite this as a number times 10 to the first. To do that, I'm just going to think in my head Here's 10 to the first, 10 to the 0, 10 to the negative first, 10 to the negative second. I need to take this decimal point behind the 4, and I need to move it 1, 2, 3 places to the left. And I'm going to add in zeros there. So now my new problem, I'm going to rewrite this. 7 times 10 to the first plus 0 point, remember I'm lining up my decimal points, 0.004 times 10 to the first. I'm going to leave this as 10 to the first because now the decimal points are the same. Adding 4 thousandths to 7 will give me this value here. For the next example, we have 5 times 10 to the negative first plus 1.6 times 10 to the negative first. I want you to pause the video and take a couple of moments to try to solve this on your own. Welcome back. Hopefully you did something similar. We have 5.0. I'm only doing this because we have this 0.6 here, times 10 to the negative first plus 1.6 times 10 to the negative first. These are the same, so I just bring this straight down. 0 plus 6 is 6. My decimal point stays. 5 plus 1 is also 6. I only have one number in front, so I don't have to do anything else to this. This is my answer. We're going to take a look at one final problem. 3.2 times 10 to the 5th plus 2.1 times 10 to the 4th. I want you to also pause this video again, take a couple of moments to solve this, and then we'll talk about the solution. Welcome back. Notice how these two are not the same place value. Going back to that number line I was looking at earlier, I'm going to have to take one of these two numbers and either move a decimal point to the left or move a decimal point to the right. So I'm just going to make this 3.2 times 10 to the 5th plus 0.21 times 10 to the 5th. So I'm moving my decimal point here, and I'm adding 1 here. 10 to the 5th doesn't change. When I add a 0 here, so I have 0 plus 1 is 1, 2 plus 2 is 4. Bring down my decimal point, 3 plus 0 is 3. So the final answer for this problem is 3.14 times 10 to the 5th.